I was 3 hours into my maintenance shift when my wrench decided to ignore gravity. Just for a second, maybe two, the magnetic clamp holding my tool belt released, and every piece of ferrous metal I carried lifted away from my hip like they were being pulled by invisible strings. My screwdriver, the spare magnetic seals, even the steel clips on my work gloves all drifted upward in perfect unison before dropping back with metallic clinks against the deck plating. The Airlock beam maintenance panel flickered, its diagnostic display showing a brief cascade of error codes before returning to normal green status lights. I stared at the readout, my breath fogging slightly in the recycled air that always ran cooler in this section. The magnetic containment seals I'd been inspecting showed optimal pressure differentials. The emergency override systems register nominal. Everything looked exactly as it should, but tools don't float on Meridian Station. Not unless something's very wrong. I pulled out my personal scanner and ran a quick electromagnetic field reading around the Airlock assembly. The device chirped once, displaying measurements that made me frown. Ambient magnetic field strength, 0.847 Tesla. Standard for this section was 0.823 Tesla, barely a 3% variance, well within acceptable parameters. Yet something had been strong enough to overcome the magnetic clamps on my tool belt, lifting several pounds of steel tools clear away from my hip. The comm unit on my shoulder crackled to life. "Cedric, you seeing anything unusual down there?" Ashling's voice carried that particular tension she got when the atmospheric processors weren't behaving. As the station's life support technician, she monitored every system that kept us breathing, and after 3 years working together, I'd learned to trust her instincts about mechanical irregularities. "Just had some tools go weightless for a moment," I reported, keeping my voice level. Readings show minor magnetic field fluctuation, but nothing outside tolerance. That matches what I'm seeing up here. The atmospheric recycling system's magnetic pumps just hiccuped. Flow rate dropped by 2% for about 30 seconds before correcting itself. Could be a power regulation issue. I sealed the maintenance panel and gathered my equipment, double-checking that everything was properly secured. The station had been my home for 18 months now, and I knew every vibration, every sound, every subtle change in the artificial atmosphere that kept us alive in the vacuum. Meridian Station wasn't just another orbital research facility. It was humanity's most advanced materials science laboratory, positioned at the L4 Lagrange point specifically because the stable gravitational environment allowed for precision experiments impossible on Earth or in low orbit. We couldn't afford system failures. Not with the Kepler project entering its final phase. The thought of Dr. Kepler's revolutionary magnetic containment research made my stomach tighten. 6 months of delicate crystal growth experiments, magnetic field manipulations that required stability measured in microtesla. If we lost containment integrity now, 18 months of work would vanish in minutes, and the project funding would disappear with it. The station would be decommissioned, the crew reassigned, and humanity would lose its best chance at developing room temperature superconductors. I made my way through the curved corridor toward the central hub, noting how my magnetic tool clips kept trying to align themselves with the bulkheads instead of hanging naturally. The deck plates beneath my feet hummed with a slightly different frequency than usual. Not enough to be alarming, but enough to notice if you'd walked these corridors every day for a year and a half. The lift carried me up 3 levels to the command section, where Breyer would be running the night shift coordination. As station commander, she had the authority to initiate emergency protocols if needed, but she also had the responsibility to keep operations running smoothly. False alarms had their own costs: crew fatigue, lost research time, expensive diagnostic procedures that found nothing wrong. But as I thought about those floating tools, about Ashling's atmospheric pumps, about the subtle changes in the station's electromagnetic signature, I couldn't shake the feeling that something fundamental had shifted. The question was whether this was the beginning of a cascade failure or just another minor glitch in a complex system operating at the edge of technological capability. I found myself thinking about the last time we'd had magnetic field irregularities. 8 months ago, when a solar storm had caused minor fluctuations in the station's electromagnetic shielding. The chief engineer at the time had dismissed it as routine space weather, right up until the moment our magnetic containment protocols triggered emergency safeguards, and we'd spent 6 hours in evacuation-ready status while the automated system stabilized. That chief engineer had been reassigned to Earth duty the following week. Now, I held his position, and the responsibility for recognizing the difference between routine anomalies and catastrophic warnings rested squarely on my shoulders. My comm unit chirped with an incoming message from Daria in communications. "Cedric, I'm getting some odd readings from the navigation array. The magnetic compass is showing a 0.3-degree drift from true, and the stellar positioning system is having to compensate for what it's classifying as local magnetic interference. Have you noticed anything in the maintenance logs? 3 systems, 3 different sections of the station, all reporting minor magnetic anomalies within the space of 20 minutes. I keep my calm. Briar, we need to talk. I'm heading to command." The reply came immediately, her voice carrying the crisp authority that had made her one of the youngest station commanders in the orbital service. Already pulling the system diagnostics, "Cedric, something's got the magnetic field generators working harder than they should be." As I walked through the corridor toward command, I passed the observation deck where Earth hung like a blue marble against the star field. Beautiful, distant, and 4 days away by emergency shuttle. If something was seriously wrong with Meridian Station, we were on our own until a rescue mission could reach us. But looking at that view, thinking about the Kepler project's potential to revolutionize energy production, about the years of careful work that had brought us to this point, I knew evacuation wasn't really an option. Not unless the situation became genuinely life-threatening. The question was, how would we know when we'd crossed that line? My tools had floated for 2 seconds. Such a small thing. But in space, small things had a way of becoming very large problems very quickly. I quickened my pace toward command, the deck plates humming their slightly off-key song beneath my boots. I found Briar in the command center, her fingers dancing across 3 different diagnostic displays while she coordinated system checks with methodical precision. The main screen showed Meridian Station's schematic with sections color-coded by operational status. Mostly green, but I could see amber warnings flickering in areas that had been solid green just hours ago. "Talk to me," she said without looking up from her console. "I'm seeing magnetic field variations in sections C through G, and the pattern suggests it's spreading outward from your location near Airlock B." I pulled up the maintenance logs on the auxiliary screen, scrolling through the automated reports that had accumulated since my shift started. It started as a localized anomaly, maybe a 3% variance in ambient field strength. But if it's reached Section G, that puts it near the primary research labs. And the Kepler containment arrays, Briar finished grimly. She highlighted a cluster of readings on her display. "Look at this progression. The magnetic fluctuations started at 2147 near Airlock B, spread to Section D at 2215, Section E at 2232, and now Section F is showing intermittent spikes." The pattern was clear and troubling. Whatever was causing the magnetic anomalies wasn't random. It was propagating through the station's infrastructure like ripples spreading across still water. My comm unit crackled. "Command, this is Ashling. I'm seeing more problems with the atmospheric recycling magnetic pumps. Flow efficiency is down 7% in sections D and E, and I'm getting pressure differential warnings in the air recycling manifolds." Briar Keeter might copy that. "Cedric's here with me. What's your assessment of life support stability?" "Stable for now, but if the magnetic pump efficiency keeps dropping, we'll start seeing atmospheric quality degradation within 6 hours. The backup chemical scrubbers can compensate, but not indefinitely." I felt the first real knot of anxiety form in my stomach, accompanied by the slight metallic taste that always seemed to accompany stress in recycled air. Life support failures didn't give you much warning before they became critical. And if the magnetic anomaly was affecting the atmosphere processors, it would likely hit other systems soon. My hands felt slightly numb, whether from stress or some subtle electromagnetic effect, I couldn't tell. Briar, we need to consider precautionary shutdown of non-essential magnetic systems, I said. If we can isolate the affected areas, we might be able to contain whatever's causing this. She pulled up the station's power distribution grid, highlighting the magnetic field generators that maintained everything from artificial gravity to the research containment fields. Problem is, almost everything on this station depends on magnetic systems. Artificial gravity, life support circulation, airlock seals, research equipment, shut down magnetics, and we're looking at emergency evacuation protocols. The main display chimed with an incoming priority message from communications. Daria's voice came through the speakers with obvious concern. Command, I'm losing signal coherence with ground control. The communications array is compensating for increasing magnetic interference, but signal strength is down 15% and dropping. At this rate, we'll lose contact with Earth within 2 hours. Briar and I exchanged glances. Losing communication with ground control wouldn't just leave us isolated. It would trigger automatic emergency protocols on Earth. If they couldn't reach us, they'd assume the worst and dispatch a rescue mission. That would mean a 4-day response time and the effective end of the Kepler project. Daria, can you compensate by boosting transmission power? Briar asked. Already tried. The power boost is being absorbed by the magnetic interference. It's like trying to shout through a thunderstorm. I pulled up the technical specifications for the station's magnetic field generators, looking for some explanation of how localized interference could spread so systematically. Briar, what if this isn't a malfunction? What if something is actively interfering with our magnetic field generators? You mean sabotage? She turned to look at me directly, her expression serious. That would require sophisticated knowledge of our systems and physical access to critical components, or remote access to the field generator control systems, I said, thinking about the strange way the anomaly was propagating. Look at this pattern. It's too regular to be random equipment failure. It's spreading at approximately 15-minute intervals between sections, always following the path of the primary magnetic field conduits. Briar pulled up the security logs, scrolling through access records for the past 24 hours. Nothing unusual in the physical access logs. But if someone had compromised our network security, the lights in the command center flickered momentarily, casting brief shadows that seemed to move independently of our positions. I felt the subtle vibration in the deck plating shift to a more irregular rhythm, and noticed that small metallic objects on Briar's desk were vibrating slightly in place. The artificial gravity felt unstable, creating that queasy sensation you get when your inner ear can't quite adjust to microgravity variations. Static electricity seemed to be building. I felt small shocks when I touched the console surfaces. That's the primary magnetic field generator cycling, I said, recognizing the harmonic pattern from months of maintenance work. They're trying to compensate for interference, but each cycle is putting more strain on the system. Ashling's voice came through the comm again, and I could hear the stress building. Command, I'm showing cascade effects in life support now. The magnetic circulation pumps in sections E and F are working at 60% efficiency and falling. I've activated the backup atmosphere processors, but they're designed for temporary use only. Briar stood up from her console, her command training kicking in as the situation escalated beyond routine maintenance issues. All right, we're looking at a system-wide magnetic field crisis. Cedric, I need you to conduct a physical inspection of the primary field generators. If this is sabotage, there might be physical evidence. What about the research labs? I asked. If the Kepler containment fields fail, Dr. Kepler's team will have to initiate emergency shutdown procedures for their experiments. The superconductor research can be restarted, but we can't restart the crew if life support fails. As if summoned by our conversation, The main display flashed a priority alert. The magnetic containment fields in Research Lab 7 were showing instability warnings. The delicate crystal matrices that had been growing for 6 months were now at risk of catastrophic deformation if the magnetic fields collapsed. I felt the weight of responsibility settle on my shoulders like a physical burden. 18 months of work, millions of dollars in research funding, and potentially revolutionary advances in material science, all dependent on maintaining magnetic field stability for a few more hours while we identified and corrected the source of the interference. But looking at the spreading pattern of anomalies, at the cascading failures in life support systems, at the communication breakdown isolating us from Earth, I was beginning to suspect that we were facing something more dangerous than equipment malfunction. The deck plates hummed with increasing irregularity beneath my feet, and I realized that the subtle wrongness I'd felt earlier was now becoming a pronounced instability in the station's fundamental systems. We were running out of time to treat this as a minor anomaly. "I'll check the field generators," I told Briar, "but we need to start considering worst-case scenarios. If we can't stabilize the magnetic systems, then we evacuate," she finished. "But not until we've exhausted every other option. Too much depends on keeping this station operational." I headed for the door, my magnetic tool clips swaying irregularly with each step as the field fluctuations continued to worsen. The corridor felt subtly different now, warmer than usual, with that particular stuffiness that meant the air circulation wasn't operating at full efficiency. Behind me, I could hear Briar initiating systematic shutdown procedures for non-critical systems, trying to reduce the load on the failing magnetic infrastructure. Her voice carried the controlled tension of someone working to stay ahead of a cascading failure. The corridor lights flickered again as I made my way toward the engineering section where the primary field generators were housed. My muscles felt slightly fatigued. The adrenaline from the initial crisis was wearing off, leaving me with the heavy tiredness that came from sustained stress. The control panels I passed showed more amber warnings than green status indicators now. Whatever was causing these anomalies was accelerating, and I had the growing certainty that we were facing something far more serious than routine equipment failure. The question was whether we could identify the source and correct it before the cascade of failures reached the point of no return. I found the first piece of evidence in Engineering Bay 2, where the primary magnetic field generators hummed with increasingly erratic rhythms. The access panel to Generator Unit 3 hung slightly ajar. Not enough to trigger security alerts, but definitely not how I'd left it during yesterday's routine maintenance. My hands trembled slightly as I opened the panel fully, whether from the electromagnetic fields or growing dread, I couldn't tell. Inside, among the familiar maze of superconducting coils and control circuits, something was wrong. A small device, no larger than a datapad, was clamped to the primary control bus. Its display showed active data streams, unauthorized access to the magnetic field control protocols. "Son of a bitch," I breathed, feeling that distinctive betrayal shock hit my chest like cold water. This wasn't equipment failure. Someone had deliberately compromised our systems. I keyed my comm with fingers that felt numb from stress. Briar, Daria, Ashling, emergency meeting in the command center. "Now, we have a problem." 10 minutes later, we stood around the command center's main display where I'd uploaded images of the unauthorized device. The evidence was undeniable. Sophisticated hardware grafted into our magnetic field control systems, actively manipulating the field generators to create the spreading anomalies. "How long has this been active?" Briar asked, her command voice steady, but I could see the tension in her jaw. "Based on the data logs, approximately 4 hours. It started small, probably testing our system's response, then began the systematic interference pattern we've been tracking." Daria leaned closer to examine the device specifications I'd pulled from its memory core. Her face went pale as she scrolled through the data streams. "This isn't just random sabotage. Look at these command protocols. They're specifically targeting our research, containment fields, and life support magnetics. Someone knew exactly which systems to compromise for maximum impact. Aisling spoke up from where she was monitoring atmospheric readings, her voice tight with controlled worry. And they're succeeding. Life support magnetic pump efficiency is down to 45% in affected sections. We're running on backup scrubbers, but they can't maintain full atmospheric quality for more than 12 hours. I felt the weight of moral responsibility settle on my shoulders like a physical burden. The evidence was clear. We've been infiltrated and sabotaged. But revealing this to the crew would likely cause panic, potentially making our situation worse. On the other hand, keeping quiet meant the saboteur was still among us, potentially planning further damage. We need to decide how to handle this, I said, looking at each of them. Do we announce to the crew that we have a saboteur? Or do we try to identify and neutralize the threat quietly? Briar's expression was grim. If we announce sabotage, we'll have 19 crew members suspicious of each other. That could destroy any cooperation we need to manage this crisis. But if we don't warn them, the saboteur could strike again, Daria finished. She pulled up the crew access logs on her display. I can trace who had access to Engineering Bay 2 in the past 48 hours, but that's still going to be 8 people with legitimate maintenance responsibilities. The deck plates beneath us vibrated with increasing irregularity, and I noticed several loose metallic objects on the command center consoles were now visibly shifting position with each magnetic pulse. The structural stress was becoming apparent. Hairline cracks were forming in the wall panels where electromagnetic forces were pulling against the station's metal framework. There's something else, I said, studying the sabotage device's programming. This isn't a standard interference pattern. The magnetic field manipulation is designed to create resonance effects, building up stress in the station's structure over time. If it continues, we're looking at potential hull breach in critical areas. Aisling's atmospheric monitors chimed with new alerts. Atmospheric pressure is dropping in Section F. The magnetic seals on the airlocks are compromised. They're not maintaining full pressure integrity. I felt my determination surge past the fear and moral uncertainty. Whatever the consequences of exposure, we couldn't allow the sabotage to continue. Briar, we have to act. Even if it causes panic, the crew has a right to know they're in danger from sabotage, not just equipment failure. Agreed, she said, moving to the station-wide communication panel. But we need to handle this carefully. If we accuse someone without proof, Daria interrupted, her voice sharp with urgency. We may not have time for careful. Look at this. She highlighted a section of the sabotage device's code on her display. There's a secondary protocol embedded in the interference pattern. If the magnetic field generators are pushed beyond 85% compensation threshold, this device will trigger a cascade failure in the primary containment systems. The implications hit me like a physical blow. The research labs. If the containment fields collapse suddenly, 6 months of Kepler project research destroyed, plus potential contamination from the materials testing. Briar finished grimly. And that's the best case scenario. Worst case, we get structural damage that compromises hull integrity. I pulled up the current compensation readings on the main display. The magnetic field generators were already running at 78% compensation, and the interference was still spreading. We have maybe 30 minutes before we hit that threshold. We need to identify the saboteur now. Aisling looked up from her atmospheric controls, her face showing the strain of managing failing life support systems. I have an idea who might have done this. Her voice was quiet but determined. Yesterday, I noticed someone had accessed the atmospheric system maintenance logs from a terminal outside environmental systems. The access was legitimate, but unusual. They were checking pump efficiency data that only gets reviewed during major overhauls. Daria immediately began tracing the access logs. I can track terminal usage patterns. If someone was gathering information about our magnetic dependent systems before installing that device. She pulled up the security access database, fingers flying over the interface. Here, Terminal 7 in Research Lab 5 was used to access atmospheric system specifications at 14:30 yesterday. But the person logged in was. Her face went pale. Someone used Dr. Chen's access credentials. The comm system crackled to life with an unfamiliar voice from environmental systems. Command, I'm showing critical pressure loss in Section G. Recommend immediate evacuation of affected areas. Breyer and I locked eyes. Dr. Chen had left the station 3 days ago on a routine supply shuttle. Someone had stolen his credentials and was using them to cover their sabotage activities. Unknown caller, identify yourself, Breyer commanded. Dr. Chen is not currently aboard the station. Static filled the comm channel for several seconds before the voice responded. This is systems maintenance. The readings are definitive. Section G is compromising atmospheric integrity. I checked the independent atmospheric sensors from my console. All readings showed normal pressure and composition in Section G. Our saboteur was lying about the emergency, trying to force an evacuation that would give them access to sabotage the research equipment directly. We have a saboteur using stolen credentials, I said grimly. And they're trying to force evacuation so they can finish the job. Breyer keyed the security protocols on her command console. Security alert. All crew members report current status and location immediately. We have evidence of unauthorized access to critical systems. The response was immediate chaos on the comm channels as crew members throughout the station acknowledged the security alert with confusion and concern. But the voice that had claimed pressure loss in Section G didn't respond to the communications check. Daria was frantically trying to trace the unauthorized transmission through the station's communication network. The signal originated from environmental systems, but I'm getting interference from the magnetic anomalies. Whoever it is, they chose their location well. The electromagnetic disturbance makes it hard to get a precise fix. The magnetic field generators groaned audibly through the station's structure as compensation reached 82%. We were running out of time to prevent the cascade failure that would destroy months of research and potentially compromise the station's structural integrity. I'm going to Engineering Bay 2 to remove that sabotage device, I said, grabbing my maintenance kit from the emergency locker. If I can disconnect it before we hit 85% compensation. Not alone, Breyer interrupted. Martinez knows we're onto him now. If he's willing to sabotage the station, he might be willing to prevent us from stopping him. Aisling looked up from her displays with grim determination. I'm coming with you. If Martinez tries to interfere, you'll need backup. And if the atmospheric systems fail while you're working on the magnetic generators, you'll need someone who knows life support systems. I felt a surge of gratitude mixed with worry for her safety. But she was right. Attempting to remove sophisticated sabotage equipment while under potential attack was not a one-person job. The three of us headed for the corridor leading to Engineering Bay 2, leaving Daria to coordinate with the rest of the crew and monitor for any further unauthorized communications. The hallway felt different now that we knew we were under deliberate attack. Every shadow could hide a saboteur. Every unusual sound could signal another compromised system. The deck plates vibrated more violently beneath our feet as the magnetic field generators strained to compensate for the ongoing interference. Structural elements of the station were beginning to groan under the electromagnetic stress, and I could see metal surfaces showing visible signs of magnetic alignment. Small metallic objects throughout the station were now pointing toward the failing field generators like iron filings around a magnet. Whatever this person's motivation, I said as we approached Engineering Bay 2, they're willing to risk the lives of 19 people to accomplish it. That makes them extremely dangerous. Breyer checked the charge on her security stunner. Industrial sabotage is one thing, but if their actions cause hull breach or life support failure, then we're dealing with attempted murder, I finished. As we reached the entrance to Engineering Bay 2, the lights flickered more severely, and the magnetic field compensation readings on the corridor displays showed 84%. We had minutes, not hours, before the cascade failure would begin. The choice was no longer between exposing sabotage or maintaining crew stability. Now, it was between stopping our unknown saboteur and watching months of research, and potentially the station itself, be destroyed by deliberate malice. I keyed the access panel to Engineering Bay 2, my heart pounding with adrenaline and determination. Whatever this person had planned, whatever their reasons for sabotaging Meridian Station, they weren't going to succeed. Not while I could still do something to stop them. The door cycled open, revealing the humming chamber where the primary magnetic field generators maintained the delicate balance that kept our artificial world functioning. And somewhere in that maze of superconducting coils and control circuits, a small device continued its systematic work of destruction. Time to end this. The Engineering Bay 2 door sealed behind us with a sound that felt ominously final. Inside, the primary magnetic field generators filled the chamber with their deep, thrumming vibration, but the rhythm was wrong, increasingly erratic, like a massive heart developing arrhythmia. The compensation readings on my handheld diagnostic unit showed 84.5% and climbing. I moved quickly to Generator Unit 3, where I'd found the sabotage device, Briar covering the entrance while Aisling monitored atmospheric readings. The small device was still clamped to the primary control bus, its display showing active interference patterns streaming into our magnetic field control systems. Cedric, Aisling's voice was tight with controlled alarm. Atmosphere pressure is dropping in sections E and F now. The magnetic seals on the airlocks are losing integrity faster than my backup scrubbers can compensate. I began carefully disconnecting the sabotage device's control leads, my hand steady despite the adrenaline. Each connection required precision. One wrong move could trigger an immediate cascade failure instead of preventing it. How long do we have on life support? Maybe 40 minutes at current degradation rate. But if the seals fail completely, she didn't need to finish. Complete atmospheric loss in any section would force immediate evacuation protocols. The device resisted removal. Its creators had designed it to be tamper-resistant. As I worked, I could see the sophistication of its construction. This wasn't improvised sabotage. It was professional-grade equipment designed specifically to infiltrate and destroy magnetic field generators. Briar, I called over the generator noise. This device is military specification. Whoever planted this has access to advanced foreign intelligence equipment. Before she could respond, the lights went out completely. Emergency lighting kicked in 3 seconds later, casting everything in hellish red illumination. Through the engineering bay's viewing port, I could see similar emergency lighting throughout the station. Main power grid failure, Aisling reported, checking her portable diagnostics. We're running on backup fusion cells, but the magnetic field generators draw too much power. We can't maintain full field strength on backup power alone. I felt system failure panic hit me like ice water in my veins. Without main power, the magnetic field generators would automatically reduce output to preserve the backup power systems. But reduced field strength with the sabotage device still active meant the interference pattern would overwhelm our weakened compensations within minutes, not hours. Compensation at 87% and rising fast. I reported, working frantically to disconnect the final control leads. Field strength dropping due to power limitations. We're hitting cascade failure threshold now. The station shuddered around us. Not the vibration of magnetic field fluctuations, but actual structural movement as electromagnetic forces pulled against the station's metal framework. Through the bulkheads, I could hear the groaning of stressed metal and the sharp crack of something breaking under strain. Briar's comm unit crackled with Daria's voice. Command, I'm showing massive system failures throughout the station. Hull sensors detect microfractures in sections C and D. Whatever's happening in engineering, it's affecting structural integrity. How long until critical failure? Briar demanded. Unknown. The magnetic stress is causing metal fatigue in load-bearing elements. Could be minutes or hours depending on. The transmission cut to static as another power fluctuation swept through the station. I finally disconnected the last control lead from the sabotage device and carefully removed it from the control bus. Immediately, the magnetic field generators began stabilizing. Compensation dropped to 79%, then 75%. But the damage was already done. The power grid failure and structural stress remained critical problems. Device removed, I reported. Field generators stabilizing. But we still have main power failure and structural damage. Aisling looked up from her atmospheric readings with grim determination. There's more. The atmospheric recycling system's magnetic pumps were damaged by the field fluctuations. I can keep us breathing for maybe 6 hours on backup chemical scrubbers, but after that, the leadership burden settled on Briar's shoulders visibly. As station commander, she had to make the choice that would determine whether 19 people lived or died. Evacuate immediately and lose the station along with 6 months of critical research, or attempt repairs with uncertain outcomes and diminishing life support. Options? She asked tersely. I studied the power distribution panel, tracing the failures through the system. Main power failure was triggered by the magnetic cascade overloading the grid relays. I can restore power, but it requires manual reset at the primary fusion reactor. That's in Section C, where hull sensors show microfractures. Atmospheric recycling repairs? Briar asked Aisling. Possible, but I need to access the pump assemblies in Section F. That's where airlock seals are compromised. Working in partial atmosphere with potential pressure loss, the sacrifice recognition hit me like a physical weight in my chest. Saving the station would require each of us to enter damaged sections where environmental systems were failing. Success wasn't guaranteed, and failure could mean death. Command, this is emergency response, came a new voice over Briar's comm. Crew members I recognized from the maintenance teams. We're showing critical structural alerts in Section C. Recommend immediate evacuation of that area. Briar looked at me grimly. That's where you need to go for the power reset. I checked the structural stress readings on my diagnostic unit. The metal fatigue was concentrated around the main support beams near the fusion reactor compartment, exactly where I needed to work. The electromagnetic forces had stressed the station's framework beyond design specifications. I can do it, I said, trying to project more confidence than I felt. But if the hull breaches while I'm in there, emergency evacuation protocols, Briar finished. The whole station would depressurize in minutes. Aisling spoke up from her atmospheric controls. I can monitor structural stress from environmental systems. If hull breach becomes imminent, I can warn you. But you'd have maybe 60 seconds to reach safe areas. The comm system crackled with reports from throughout the station. Power failures in research labs, atmospheric pressure warnings in multiple sections, and structural stress alerts in critical areas. Our crew was reporting problems faster than we could catalog them, let alone fix them. Commander, came Daria's voice over the comm. I've isolated our saboteur's location. He's in Section D, near the research containment systems. Hull sensors show he's attempting to access the primary research storage. The implication was clear. Even with the magnetic field stabilized, our saboteur was still active, still trying to complete whatever mission had brought him here. In Section D was where we stored the most sensitive Kepler project materials. If those containment systems failed, he's going for the research materials directly. I realized, with the magnetic containment fields destabilized, he might be able to breach the storage systems manually. Briar's face showed the terrible burden of command as she weighed impossible choices. Restore power to save the station, but risk hull breach. Repair atmospheric systems, but risk depressurization. Stop the saboteur, but leave critical systems unrepaired. We split up, she decided. Cedric, attempt power restoration in Section C. Aisling, atmospheric repairs in Section F. I'll pursue our saboteur in Section D. I started to protest. Splitting up meant none of us would have backup if something went wrong. But the mathematics of the crisis were undeniable. We had 3 critical failures requiring immediate attention, and 3 people capable of addressing them. What if the hull breaches while we're separated? I asked. Then we try to reach safe areas and hope the emergency bulkheads hold, Breyer said grimly. But if we don't act now, the station fails anyway. At least this way, we have a chance. The station groaned around us again, and my diagnostic readings showed structural stress continuing to increase in multiple sections. Metal fatigue was progressing faster than predicted. The electromagnetic cascade had damaged more than just our power systems. Emergency protocols, Breyer announced over station communications. All non-essential personnel report to central safe areas. Essential systems personnel remain at stations. We have critical repairs in progress. I gathered my equipment, including the removed sabotage device as evidence, and prepared to head for Section C. The fusion reactor manual reset required specialized knowledge and tools. If I failed, we'd lose main power permanently. Aisling checked her portable atmospheric equipment, face set with quiet determination. If the airlock seals fail completely while I'm working on the pumps, emergency pressure suits are stationed in Section F, I reminded her. But they only have 4 hours of air supply. Better than suffocating in 6 hours when the scrubbers fail, she replied with grim humor. Breyer checked her security equipment and studied the layout of Section D on her display. If our saboteur is willing to risk hull breach to access the research materials, he's either desperate or working under orders that consider the station expendable. We stood at the engineering bay exit, about to separate into the damaged sections of our failing station. Each of us faced significant risk of death, and success wasn't guaranteed even if we all survived our individual missions. Maintain calm contact, Breyer ordered. If anyone encounters problems beyond your ability to handle alone, call for help immediately. Saving the station isn't worth losing crew members. I keyed the door release, and we stepped into the corridor where emergency lighting cast everything in red shadows. The deck plates vibrated irregularly under our feet, and I could hear the station's structure groaning under ongoing stress. Section C for power restoration, I confirmed, heading toward the reactor compartment. Section F for atmospheric repair, Aisling acknowledged, moving toward environmental systems. Section D to stop our saboteur, Breyer said, disappearing toward the research areas. As I made my way through corridors filled with emergency lighting and the sounds of a station in distress, I realized we were attempting something with no guarantee of success. But the alternative, evacuation and total loss of the station, was unacceptable. The fusion reactor compartment lay ahead, in a section where hull microfractures were spreading through overstressed metal. If the hull breached while I was performing the manual power reset, I pushed the thought away and focused on the task ahead. Somewhere in the station, Aisling was risking depressurization to repair atmospheric systems. Somewhere else, Breyer was confronting a saboteur who had already demonstrated willingness to kill 19 people to complete his mission. The weight of sacrifice recognition settled over me like a physical burden. We might save the station, but the cost would be measured in more than damaged equipment and lost research. Some of us might not survive the next hour, but as I reached the access panel to Section C, I felt my determination solidify into something harder than fear. Whatever the risks, whatever the costs, we weren't going to let sabotage and system failures destroy what we'd built here. The station's survival depended on 3 people, separated and working against time in damaged sections where environmental systems were failing. It should have felt hopeless. Instead, as I keyed the access to the reactor compartment, it felt like our only chance. The reactor compartment access hatch cycled open with a grinding sound that spoke of damaged mechanisms. I stepped into Section C, immediately feeling the difference in the atmosphere. Thinner, with a metallic taste that suggested atmospheric recycling was already failing here. My handheld diagnostics showed structural stress readings that made my stomach clench. Microfractures in the primary hull supports were expanding faster than predicted. The fusion reactor itself hummed with contained power, but the control panels around it were dark, their magnetic storage systems wiped clean by the cascade failure. The manual reset controls were located at the reactor's base, requiring me to crawl through a maintenance space where stressed metal groaned ominously overhead. Cedric to command, I spoke into my comm unit. Structural damage is worse than we thought. I can see hairline cracks spreading along the main support beam above the reactor controls. Breyer's voice crackled back through increasing static. How long do you need for the reset? I studied the manual reset procedure on my portable diagnostic unit, mapping out the required steps. Minimum 15 minutes to safely restart the fusion reaction and synchronize power distribution. But if that support beam fails, the entire reactor compartment could decompress, she finished grimly. Status on our saboteur, still pursuing. He's reached the primary research containment area. Daria confirms he's attempting to access the Kepler project materials directly. The desperation hit me then, not panic, but the cold realization that we were running out of options. If I couldn't restore main power, Aisling couldn't repair the atmospheric systems properly. If the atmospheric systems failed completely, we'd be forced to evacuate regardless of other repairs. And if our saboteur breached the research containment while systems were unstable. Aisling, what's your status? I asked, crawling toward the reactor's manual controls. Atmospheric pump assemblies are accessible, but airlock seal failure is accelerating. I'm working in a section that's losing pressure at roughly 2% per minute. At this rate, I'll need emergency pressure gear within the hour. The guilt confrontation felt like acid in my throat. I should have caught the sabotage earlier. The device I'd found on Generator Unit 3 had been sophisticated, but not invisible. A more thorough inspection might have detected it before the cascade failure began. Now Aisling was risking asphyxiation because of my oversight. There's something else, I said, reaching the manual reset controls and beginning the preliminary shutdown sequence. The sabotage device I removed, it was designed specifically for our magnetic field generators. Whoever provided it had detailed knowledge of our systems. Inside information. Breyer's voice was tight with controlled anger. Our saboteur had help from someone with access to station technical specifications. I initiated the controlled shutdown of the fusion reactor, watching power levels drop across all station systems. For the next 10 minutes, we'd be running on emergency batteries only. No artificial gravity, minimal life support, and no magnetic containment fields. The station would be completely vulnerable. Through the reactor compartment's viewing port, I could see the rest of the station settling into emergency power mode. The artificial gravity cut out, and I felt my stomach lurch as everything went weightless. In zero gravity, the structural stress from metal fatigue would redistribute, potentially making hull breach even more likely. Gravity's out, I reported unnecessarily. Everyone on station would feel it. Beginning fusion reaction restart sequence now. The manual controls required precise timing and sequence activation. Each step had to be completed exactly right, or the fusion reaction could destabilize catastrophically. I worked methodically, checking each parameter against the diagnostic readings, but I could hear the support beam above me groaning under redistributed stress. Cedric, Aisling's voice carried new urgency. Atmospheric pressure in Section F just dropped below safety thresholds. I'm switching to emergency breathing apparatus, but I can only work for another 30 minutes before I need to evacuate. How long for the pump repairs? 25 minutes if everything goes perfectly. But if there are complications, she didn't need to finish. In zero gravity, with failing atmospheric pressure, any unexpected problem could be fatal. My comm unit crackled with Daria's voice. Command, structural sensors show hull breach probability exceeding critical thresholds in multiple sections. The metal fatigue is cascading faster than our models predicted. Specific timeline? Breyer asked. Unknown. Could be minutes, could be hours. The electromagnetic stress caused microscopic damage throughout the station's framework. Every vibration, every temperature change is accelerating the failure process. I completed the fusion reaction restart sequence and began synchronizing power distribution. The reactor hummed back to life, and I felt a moment of relief as main power began flowing to station systems. But then my diagnostics showed a new problem. Power grid relays damaged by the magnetic cascade weren't accepting full load. Main power restored, but we're only getting about 60% capacity, I reported. The magnetic field generators will stabilize, but full environmental systems are still compromised. Enough for life support? Breyer asked. Barely. But if we lose any more power grid components? The final commitment crystallized in my mind as I realized what we were really attempting. We weren't just trying to save the station. We were betting 19 lives that we could repair critical systems before hull failure killed us all. And the odds are getting worse by the minute. Breyer, I said, we need to consider evacuation protocols. Even if we complete all repairs, the structural damage may be irreparable. This station might be on borrowed time regardless of what we do. Negative. Our saboteur just breached the primary research containment. If he accesses the Kepler project materials and escapes with them. Her voice trailed off, but the implication was clear. The research we'd been conducting wasn't just scientifically valuable. It was strategically critical. I pulled myself out of the reactor maintenance space and back toward the compartment exit, trying to ignore the ominous creaking from the support beams. Heading back to Engineering Bay 2 to monitor magnetic field stability. Ashling, status on atmospheric repairs. Pump assemblies responding to repairs. But I'm finding more damage than expected. The magnetic cascade affected the molecular separation filters. I can restore basic atmospheric recycling, but contamination filtering is compromised. Meaning, we'll have breathable air, but trace toxins from damaged systems will accumulate over time. Long-term health effects are uncertain. The point of no return wasn't a moment. It was a realization. Even if we succeeded in all our immediate objectives, the station would never be the same. We'd saved it, but at cost we were still discovering. Structural integrity compromised, atmospheric systems damaged, and crew trust shattered by sabotage. I reached the corridor junction where we'd separated, now traveling in zero gravity using handholds along the bulkheads. The emergency lighting cast shifting shadows as station systems fluctuated under reduced power load. Cedric, to all personnel, I announced over general communications. Main power restored at 60% capacity. Magnetic field generators stabilizing. But structural damage remains critical. Avoid unnecessary movement through sections C and D. Moving through the corridors toward Engineering Bay 2, I could see evidence of the cascade failure everywhere. Control panels displaying error messages, atmospheric vents producing irregular airflow, and the subtle but unmistakable signs of a station operating at the edge of its capabilities. My comm unit crackled with updates from crew members throughout the station. Research teams were reporting data corruption in multiple experiments. Maintenance personnel were finding damaged equipment in every section. Even basic navigation systems were showing errors from magnetic field disruptions. Engineering Bay 2 accessed, I reported, pulling myself through the hatch. Magnetic field generators are stabilized at acceptable levels, but compensation systems are still showing residual interference patterns. I ran diagnostics on all the magnetic containment systems, searching for any remaining effects from the sabotage device. The readings showed our magnetic fields were stable but weaker than normal, operating within acceptable parameters, but with no margin for error. Breyer, any progress with the saboteur? Cornered him in Research Lab 7. He's accessed preliminary Kepler project data, but not the core materials. Attempting negotiation, but he's indicated willingness to use explosive charges if cornered. My blood went cold. Explosive charges in a station already weakened by structural damage could trigger complete hull failure. What kind of explosives? Unknown. But given his access to sophisticated sabotage equipment, we have to assume military-grade capabilities. The desperation was no longer about saving the station. It was about preventing a catastrophic explosion that would kill everyone aboard and destroy 6 months of critical research. The saboteur had moved beyond intelligence gathering to scorched earth tactics. Ashling, how much longer on atmospheric repairs? 15 minutes for basic function restoration. But I'm working in an atmosphere that's 30% below normal pressure. If I make any mistakes, I could hear the strain in her voice. She was pushing herself beyond safe limits, risking unconsciousness from oxygen deprivation, because failure meant the entire crew would slowly suffocate. The station shuddered around us again. Not the electromagnetic vibration of magnetic field fluctuations, but the deeper, more ominous sound of metal under extreme stress. Through the engineering bay's viewing port, I could see subtle changes in the station's geometry as damaged supports redistributed load. Structural alert, came Daria's voice over the comm system. Hull breach probability now critical in sections C and D. Recommend immediate evacuation of those areas. But Section D was where Breyer was confronting our saboteur. And Section C was where I'd just completed the reactor restart. We were being forced out of the areas we needed to defend. Breyer, you need to get out of Section D, I said urgently. Negative. If the saboteur detonates explosives in Research Lab 7, the blast will compromise primary research storage and potentially trigger hull breach. I have to stop him here. I realized she was making the same calculation I'd made in the reactor compartment, accepting mortal risk because the alternative was unacceptable. We'd moved beyond weighing odds to accepting that some things were worth dying for. All stations, this is engineering, I announced over general communications. Prepare for potential emergency evacuation. Have pressure suits and emergency supplies ready, but maintain positions until ordered otherwise. Looking at my diagnostics, I could see the full scope of what we were attempting. Magnetic field generators stabilized, but weakened. Main power restored but reduced. Atmospheric systems partially repaired but compromised. Structural integrity questionable. And somewhere in the damaged sections, our commander was risking her life to prevent our saboteur from completing his mission. The final commitment wasn't a decision, it was an acceptance. We'd chosen to risk everything rather than abandon what we'd built. Whether we succeeded or failed, none of us would be the same after tonight. I activated the magnetic field diagnostic sequence, preparing to monitor our containment systems through whatever came next. The readings showed stable but fragile equilibrium, like a house of cards that would stand as long as no one breathed on it wrong. Outside the engineering bay, I could hear the station settling into its new reality. Reduced power, compromised atmospheric systems, weakened structural integrity, and the constant threat that the saboteur's explosives could end everything in seconds. But we were still here, still fighting, still refusing to let sabotage and system failures destroy what 19 people had spent months building. The sacrifice wasn't what we'd lost, it was what we were willing to lose. And as I monitored the readings that would tell us whether we'd live or die, I realized that sometimes the only way to save something is to risk destroying it completely. The point of no return lay behind us now. Whatever happened next, we'd chosen to face it together, in a damaged station held together by determination and the stubborn refusal to accept defeat. The explosion in Research Lab 7 sent shock waves through the station's compromised hull, and I felt the engineering bay's bulkheads flex dangerously around me. My diagnostic screens flickered as the blast's electromagnetic pulse interfered with the already fragile magnetic field generators. But the readings stabilized after several terrifying seconds of wild fluctuation. Breyer, report. I called into my comm unit, gripping the control panel as artificial gravity fluctuated. Static filled the channel before her voice came through, strained but alive. Explosive was smaller than expected, probably designed to destroy data rather than breach hull. Saboteur neutralized, but he managed to corrupt the primary Kepler project database before detonation. Through the engineering bay's viewing port, I could see emergency lighting flickering in Section D where the blast had occurred. The station's structural sensors showed new stress fractures, but the hull was holding. Our saboteur had chosen data destruction over mass murder, perhaps retaining some vestige of conscience, or simply calculating that a dead station crew would raise too many questions. Ashling, status on atmospheric repairs? I asked, running diagnostics on all magnetic containment systems to ensure they'd survive the blast. Atmospheric pumps are online and functional. Her voice carried exhaustion but determination. Pressure stabilized at 85% of normal throughout all sections. Contamination filtering is operational but reduced capacity. We'll need to monitor air quality closely for the next several weeks. The magnetic field generators showed stable readings across all parameters. Not optimal. We were operating at roughly 70% of normal field strength, but within acceptable limits for long-term station operation. The sabotage device I'd removed from Generator Unit 3 had caused cascading damage, but the manual reset had prevented complete system failure. I pulled myself through the zero-gravity environment toward the main engineering console, where comprehensive station diagnostics awaited my review. The full scope of our situation was becoming clear. We'd prevented catastrophic failure, but at significant cost. Daria, can you give me a complete structural assessment? I asked, initiating power grid optimization protocols to maximize our reduced electrical capacity. Hull integrity is maintained, but we have stress fractures in sections C and D that will require extensive repair. Her voice carried the precision of someone reading from multiple sensor displays. The metal fatigue from magnetic field fluctuations caused microscopic damage throughout the station's framework. Structural load capacity is reduced by approximately 20%. Breyer's voice crackled through the comm system. All personnel, this is command. Immediate crisis is contained. Saboteur has been neutralized and secured. However, station operations will be modified pending full damage assessment. I reviewed the power distribution systems, balancing electrical load across damaged grid components. We had main power, but several relay stations had been destroyed by the magnetic cascade. Engineering to command, I reported. Main power stable at 65% capacity. Sufficient for life support and essential systems, but research activities will need to be prioritized. The action clarity I felt now was different from the desperate focus of crisis management. This was the methodical precision of damage control, assessing what we'd saved, what we'd lost, and what we could rebuild. The magnetic field generators hummed with contained stability, no longer fluctuating wildly, but I could hear subtle harmonics that hadn't been there before. Ashling, join me in Engineering Bay 2, I requested. I want to review atmospheric system integration with the stabilized magnetic fields. She arrived within minutes, moving carefully through the zero-gravity corridors using handholds along the bulkheads. Her face showed the strain of working in reduced atmospheric pressure, but her eyes held the satisfaction of someone who'd completed a nearly impossible repair under extreme conditions. The atmospheric recycling systems are functional, she reported, reviewing her portable diagnostic readings. But the molecular separation filters sustained damage from the electromagnetic interference. We can maintain breathable atmosphere, but trace contaminants will accumulate slowly over time. I nodded, studying the integrated systems display. How slowly? Conservative estimate suggests we can operate normally for approximately 6 months before health effects become significant. But that assumes no additional equipment failures. The victory cost was becoming quantifiable. Stations saved and operational, but with reduced capacity and limited operational lifespan. We'd prevented immediate catastrophe, but created long-term challenges that would affect every aspect of our mission. Breyer's voice came over the general communication system. All research teams report to your respective section leaders for damage assessment. Priority will be given to experiments that can be completed with current power and atmospheric limitations. I activated the comprehensive diagnostic sequence, running system checks on every magnetic containment field, power distribution node, and atmosphere processing unit. The readings painted a picture of damaged but functional infrastructure, like a building that had survived an earthquake but would never be quite the same. The Kepler project data loss. I asked Breyer over a private channel. How extensive? Primary database corrupted, but we maintained secondary backups in isolated storage. Approximately 60% of experimental data is recoverable. 6 months of research reduced to 3 months of usable results. The aftermath reflection hit me as I contemplated what we'd accomplished and what it had cost. We'd saved 19 lives and preserved the station's operational capacity. But we'd lost critical research data, compromised long-term sustainability, and shattered the trust that comes from believing your workplace is secure from sabotage. Cedric, Aisling said quietly, studying her atmospheric monitoring readings. The trace contaminants I mentioned, they're not just industrial pollutants. The magnetic cascade caused molecular breakdown in some of our synthetic materials. We're going to be breathing microscopic metal particles for months. Long-term health effects, another cost we'd have to live with. Not immediately dangerous, but a constant reminder that our victory had come with prices we were still discovering. I reviewed the power grid status, noting which systems had survived the cascade and which would need replacement. We can maintain essential operations indefinitely, I concluded. But research capacity is reduced to about half of original capabilities. Daria's voice came over the comm system with updates from damage assessment teams throughout the station. Sections A and B show minimal damage. Section C has stress fractures but remains habitable. Section D is structurally compromised. Recommend restricted access pending repair. Section E shows electromagnetic interference effects but no major damage. The station's new configuration was emerging: a reduced operational area, limited research capacity, compromised atmospheric systems, and the constant awareness that we were operating with damaged safety margins. All personnel, Breyer announced over general communications. Station operations will continue, but with modified protocols. Research activities will be prioritized based on available resources. Atmospheric monitoring will be conducted continuously. Structural load limits must be observed in all damaged sections. I floated in the engineering bay, surrounded by diagnostic displays showing the new reality of our station's capabilities. The magnetic field generators provided stable containment, but at reduced strength. The power grid supplied essential systems, but with no redundancy. The atmospheric systems maintained breathable air, but with accumulating contamination. We'd achieved our hard-won success. Mission accomplished, station operational, crew alive. But the great cost was becoming more apparent with each diagnostic reading. Reduced capabilities, health risks, lost research, and the psychological impact of knowing that someone among us had been willing to destroy everything we'd built. The consequences we'd have to live with weren't just technical, they were personal. Aisling would monitor atmospheric contamination levels for months, knowing that every breath carried microscopic reminders of our damaged systems. Breyer would command a station operating at reduced capacity, constantly balancing research priorities against safety limitations. Daria would maintain communication and navigation systems that had been permanently affected by electromagnetic interference, and I would monitor magnetic field generators that hummed with contained stability but would never again operate at full strength. A constant reminder that sabotage had left permanent scars on systems I was responsible for protecting. Engineering to all stations, I announced over the general communication system. Magnetic field generators stabilized and operational. All containment fields within acceptable parameters for continued station operations. Primary crisis successfully resolved. But as I looked at the diagnostic readings showing our damaged but functional systems, I understood that resolution didn't mean restoration. We'd saved the station, prevented catastrophic failure, and maintained our ability to continue our mission. The price had been reduced capabilities, compromised safety margins, and the knowledge that our isolated research facility was more vulnerable than we'd ever imagined. The magnetic anomaly that had started with tools floating briefly near Airlock had revealed systematic sabotage, triggered cascading system failures, and forced us to choose between evacuation and accepting mortal risk to save our work. We'd chosen a fight, and we'd won. But victory in crisis management isn't about returning to normal. It's about learning to operate effectively in whatever new normal emerges from the damage. As I floated in the engineering bay, monitoring the steady readings from our stabilized magnetic field generators, I realized that sometimes the greatest success is simply surviving with enough intact to keep going. We'd lost data, capacity, and peace of mind, but we'd gained something too. The knowledge that when everything went wrong, 19 people had chosen to risk everything rather than abandon what they'd built together. The station hummed around us with damaged but determined persistence. Not quite the same as it had been, but still ours, still functional, still home to the research that someone had tried so hard to destroy. We'd saved it, and now we'd learned to live with what that salvation had cost us.